right, good day, everyone. You are welcome back to our channel. In the previous video, we looked at the solution to question 8. In this current video, we'll be looking at solutions to question 9. All right, let's get to it. Question 9. The graph of f of x equals as cubed plus bs squared plus cx minus 5 is drawn below. E has a coordinate of -1 and 0, and G has a coordinate of 5 and 0. And those are the x-intercepts of F. The first question is show that A equals 1, B equals -3, and C equals -9. So let's solve that question. So the first thing you want to do is to make your life easier. So we can set that f of x to equation 1. Then here, we know that this is the general form of a cubic function. So we have a root of a cubic function here, and we have another root here because those are the x-intercepts. So here we have a double root here. We have a double root here. So that is why you see that I wrote x plus 1 all squared. That is, this point represents a double root. You can see here. And the second root we have is at x equals 5, right? So for x to be equal to 5, you can write that as x minus 5. You know that if you set x minus 5 to 0, x will eventually be 5, which is what you have here. So that is how we write equation of this type. Next, we can simplify that equation. So if we simplify that equation, if you expand x plus 1 all squared, you will have x squared plus 2x plus 1. Then multiply by x minus 5. So if we drill down, if we expand this bracket, we will have a bracket s cubed plus 2s squared plus x minus 5s squared minus 10x minus 5. So we simplify this further, and simplification gives us a into s cubed minus 3s squared minus 9x minus 5. So next, we can just, since this is also f of x, we just call this equation 2. If you compare equation 2 with equation 1, both of them are f of x. So since f of x is equal to f of x, then you can equate the two equations. That is, you can equate equation 1 to equation 2. So let's see how that works out. So it means that equation 1, which is this, will be equal to equation 2, which is what we have here, right? So the next thing we can do is to equate the coefficient, right? So we equate the coefficient of s cubed, s squared, x, and we also equate the constant as well. So on the left-hand side, the coefficient of s cubed is a. On the right-hand side, the coefficient of s cubed is also a. So a equals a. So there's nothing much we can do with that. Now, let's equate the coefficient of s squared. On the right-hand side, the coefficient, on the left-hand side, rather, the coefficient of s squared is b. And on the right-hand side, the coefficient of s squared is 3a. So we equate those two coefficients. Now, let's equate the coefficient of x on both sides. On the left-hand side, the coefficient of x is c, and the coefficient of x on the right-hand side is negative 9a. So we equate those two. Now, let's equate the constant on both sides. On the left-hand side, the constant, that is the term that does not have x with it, the constant on the left-hand side is negative 5. However, on the right-hand side, the constant is negative 5a. So we equate negative 5 to negative 5a, which means that a equals 1. We just make a the subject here. A will be equal to 1. Now, since a equals 1, easily we can solve for b and c. We can substitute a equals 1 into equation 3. This equation we have here. So that means that b will be equal to negative 3 multiplied by 1, which means that b equals negative 3. We can calculate c. So if we substitute a equals 1 into equation 4, this is equation 4 here. So it means that c will be equal to negative 9 multiplied by 1. That means that c equals negative 9. So that answers question 9.1. Question 9.2. It says calculate the value of x for which f has a local minimum. So when you are dealing with cubic function, the highest point, the turning point, the higher turning point represents the local maximum, and the lower turning point represents the local minimum. So in this case, the local minimum will be here. So they want us to calculate the s coordinate at this point. Now, to calculate the s coordinate at the turning point of a cubic graph, you have to find the first derivative of the cubic function. The first derivative of the cubic function will lead to a quadratic equation, which you can solve quadratically. So f of x equals this. You just need to substitute the value of a, b, and c, which you have calculated in question 9.1. So that is f of x. Then next, we have to find the first derivative of f of x, and that will be 3x squared minus 6x minus 9. Now we have to solve this equation quadratically. So for those of you that like to do the manual method, you can factorize. And like I always say, nobody forces you to factorize. So we have negative 6, that will be positive 6 there, plus the square root of negative 6 squared. Negative 6 all squared minus 4 into a. Our a is 3. Then multiplied by negative 9. Multiplied by negative 9. So it is negative 9. Then we close the bracket, then we use the down button, divided by 2a. So 2a will be 2 times 3. So that will be 6. So it means that one of the values of x will be 3. Now, let's check for the second values of x, for the second value of x. So the second value of x will be negative 1. So the two values of x for this equation are negative 1 and positive 3. So it means that the s coordinate you are seeing here, this is negative 1. That is the lower root that we just calculated. And that implies that the x coordinate at this second turning point will be 3, right? It will be 3. So that is how you calculate the s coordinate at the turning point for a cubic function. Let me remind you once again, to calculate the s coordinate at the turning point of a cubic function, all you need to do is to find the first derivative of the cubic function. Then you solve that first derivative quadratically to get the two roots. of the first derivative. So the two roots of the first derivative would give the s coordinates at the two turning points of the cubic function. So here, s coordinate is -1, and here the s coordinate would be 3. So that is what they asked us to calculate here. This is the local minimum. So the s coordinate there would be 3. Now, we can also calculate the corresponding y coordinate at this point, though we were not told to calculate that, but we would need that y coordinate later. So to calculate the y coordinate at this local minimum, since the s coordinate here is 3, all we need to do is to substitute x equals 3 into the original cubic function. And if we do that, if we substitute x equals 3 into this original function, we will get a value of -32. So which means that the corresponding y coordinates at this local minimum will be -32. So the coordinate at this local minimum will be x equals 3 and y equals -32. It's important to know that, and we'll be using that. So for those of you that like to practice with factorization, this is it. I've broken it down here to calculate the two values of x. So you can see here that x will be equal to 3 or x equals -1, which is exactly the same thing that we got when we use calculator. So you can just write the statement here that therefore the value of x at the local minimum would be 3. Now question 9.3. Use the graph to determine the values of x for which the second derivative of f of x, that is f prime prime of x, multiplied by f of x is greater than 0. To solve this question, we will have to get the second derivative of f of x. So we derive f of x twice. So if we do that, if we derive f of x twice, then we will get f prime prime of x. That is the second derivative of the function. If f prime of x, the first derivative of x, equals 3x squared minus 6x minus 9, it means that f prime prime of x, the second derivative of x, would be equal to 6x minus 6x, right? So we derive this again the second time, and that will give us f prime prime of x, and it will be 6x minus 6x. So if we have 6x minus 6x, then we can calculate the x-intercept. So the x-intercept there would be when y equal to 0. So if you substitute y equal to 0 into the equation of the second derivative, it means 0 will be equal to 6x minus 6. If you make x the subject of the formula, it means that x will be equal to 1. Very important. So x will be equal to 1, right? And at this point, x is equal to 1 and y will be equal to 0. So this is the x-intercept of the second derivative of f of x, which is f prime prime of x. So that is that. So it means the x-intercept of f prime prime of x is 1, 0. We can also calculate the y-intercept of f prime prime of f prime prime by substituting x equals 0. So if we substitute x equals 0 into the equation of the second derivative, we will have a y value of -6. And that is the reason you see this graph here. the x-intercept is at x equals 1 and y equals 0. And here you have the y-intercept, which has a coordinate of x equals 0 and y equals -6. Right. So let's look at the question again. So the question that use the graph to determine the values of x for which f prime prime of x, the second derivative of x, multiplied by f of x, the original function, is greater than 0. So we will look at that graph that we saw a while ago. We will look at this graph, right? And there are two scenarios where the multiplication of the second derivative and the original function will be greater than 0. If anything is greater than 0, it means you are dealing with positive sign. You are dealing with a positive number, right? So what we can do, so this is the y-intercept there. So now for us to have this condition where f prime prime of x, the second derivative multiplied by the original function, is greater than 0. And like I said, if something is greater than 0, it means it's positive, right? Yeah, positive times positive. If f prime prime of x, that is this linear line, if it's positive, and if f of x is positive at the same time, if you multiply positive by positive, you will have positive, which fulfills this condition greater than 0. Another situation where you can have positive is if the second derivative is negative and the original function is also negative. Negative times negative will give us positive. So we can look on the graph and see those regions. And it's a tricky question, so to speak, because if you look at this point, the x coordinate here is 1. The s coordinate at this point is -1. So you would see between these 2 points, we can see that the graph, we can see that this linear line, that is the graph of f prime prime, the second derivative, will be negative below x value of 1. So any x value that is less than 1 will correspond to a negative linear graph, right? If you shift to the left of this linear graph will be below it will be, if you shift to the left of this x equals 1, you will have this graph, this linear graph, in the negative y-axis, right? So for x values less than 1, this straight line will be negative. And you can also see here that at this point where x equals 1, this original cubic function f is also in the negative y-axis, right? So even up to this point, just slightly before this point, f of x, the curve, is also in the negative y-axis. But at this point, you will see that f of x is not in the negative axis, it's at point y equal to 0. So that means that this exact point does not qualify for y equals negative, for negative y. So it means that the values of x between this point and those exact points are excluded, right? So the values of x between this point and this point fulfill this condition, negative, negative for both curve, And it means that the multiplication of those two will be greater than 0 because you are dealing with negative linear graph and negative curve, right? So there we can see this condition. So it means that between these 2 points, we have -1 less than x and x less than 1. It means between these 2 points, you are not counting this point, this exact point. You are not counting this exact point. You are just looking for the values of x in between them. Then also, immediately you go past this turning point at E, immediately you go left of this point, you will see that the graph of f of x will be in the negative y-axis. Also, beyond that point, we can also see that the graph of this f prime prime of x, the linear line, would also be in the negative. So that means that any value of x that is less than 1. So let's rewrite this. Okay. So that means that any value of x that is less than -1 would also satisfy this condition, right? Because beyond this, the graph of f of x, the curve, will be in the negative axis. And as a matter of fact, we can see clearly that this straight line, the second derivative, would also be in the negative y-axis. The reason I didn't include this point, x equals 1, is that at this point, if x equals 1, this point is at y equal to 0, right? So if you multiply 0 with negative, you will end up with 0. But the inequality we are dealing with here is greater than 0. Therefore, we cannot include this point, and we cannot include this point as well, right? So any point to the left of x equals -1, which is here, which is what I represent here, will fulfill this condition. And any value of x between these two values, x equals -1 and x equals 1, would also fulfill this condition. Another point that would fulfill this condition is any value of x greater than 5. If you look at this curve at point G, x equals 5. For any value of x that lies to the right of this point x equals 5, this curve of g of x will be in the positive y-axis. And of course, you can see that even from here, this straight line is positive. So it means that for any value of x that is greater than 5, this curve will be in the place positive, and this linear line would also be in the positive. So that will be positive times positive, which is the first condition here, which will be positive, which fulfill this condition. So we have one more range, or one more possible values of x, and that will be x greater than 5. So for x greater than 5, these two curves will be in the positive, and that will be positive times positive. So this answers question 9.3. Okay, let's solve question 9.4. For question 9.4, the question says, for which values of t will the graph of p of x equals f of x plus t have two distinct positive roots and one negative root? Okay, so let's look at that. Let's work something out. So P of X equals F of X plus T. Okay, so this T involves a shift in Y value. So it involves Y shift. So we need Y coordinates at the local minimum and maximum. Of course, the Y coordinate at the local maximum is 0. What you have here, the Y coordinate here, and the Y coordinate at the local minimum is negative 32. We have calculated that in the previous question. So we can see the Y coordinate at the local maximum is 0. Now, X coordinate at the local minimum is 3. So if X coordinate at the local minimum, this point is 3, then we can calculate the corresponding Y coordinate there, which we have done in the previous question. But for the sake of emphasis, let's look at it again. So all we need to do to calculate the corresponding value of Y here is to substitute X equals 3. And that gives a value of negative 32. So that gives a value of negative 32. Now, if we look at the curve, right? So this is the local minimum. And at the local minimum, the Y coordinate is 32. That is the most important point there. So now, in order to get a single negative root and 2 positive roots, then we have to shift this curve up. So we have 2 negative roots, which is negative 1 and negative 1. Then we have 1 positive root here, which is X equals 3. But the question wants us to shift this curve such that we would have only 1 negative root and 2 positive roots. So what we can do in order to achieve that, and that is very glaring from here, you can see that this is plus T. The shift is not inside of this bracket. If the shift was if the number was in front, or if the variable is in front of X, that would have been shift in X. But the variable is separate here, which shows that we are dealing with Y shift. So what we can do is to move this curve up. If we move this curve up to a Y value greater than 0. So if we move this up by more than 0 units, then we would see that we will arrive at a situation where we can get 1 negative root here and 2 positive roots here, right? But if we shift this up by more than 0 units, it is important that we don't go beyond 32 units. That is in terms of vertical shift. If we go up to 32 units for the vertical shift, this is what happens. So let's look at this. If we shift up by more than 0, so you can see now that gradually here at this point, we have 2 negative roots, one here and the other there. And at the moment, we still have one positive root. We still have 1 positive root here at the moment. So let's continue to shift forward. Let's shift upward. So you can see here that at this point, we are having 3 distinct roots. 1 root here, but we are not sure of the exact coordinate of X here. We are not sure the coordinate of X here will be 0, and we are not sure of the coordinate of X here, right? Remember, they said that we should shift it in such a way that we have 1 negative root and 2 positive roots. All right, so let's continue the shift. So you can see now. Good. So from this point on, we have 1 distinct negative root, then we are starting to have the positive root. So if you continue to shift forward, you can see now that the positive roots are very obvious, and the negative root is obvious as well. But you don't want to shift this graph beyond a vertical shift of 32. If the shift is equal to 32 units upward, this is what happens. This happens. Remember, this graph still goes downward, so you will still have one distinct negative root at this point. But here now, you would only have a double positive root, which is not distinct. So that is why you don't want to have a vertical shift equal to or greater than 32. So your shift must be, your y shift or your vertical shift must be greater than 0, but that shift must be less than 32 units upward in order to achieve this situation where you have one distinct root, one distinct negative root, and two distinct positive roots. So the question is just as simple as that. So one thing you need to take into account is you just have to calculate the y coordinate at the local minimum, which is negative 32, and you have to shift this graph in such a way to have one distinct and one distinct negative root and two distinct positive roots. And that is the question. So the value of t will be any value of t that is greater than 0, but the value of t must be less than 32. The value of t must be less than 32. So you cannot shift beyond 32 units upward. So the value of t, the shift, must be less than 32. So that solves that question. Thank you so much for staying with us till the end of question 9. Next, we will be looking at question 10. All right, bye for now.